Morning, good afternoon, good evening, boys and girls. How are we all doing today? Now, with the very generous acceptance of our sponsors for today, we are going to bring you a bedtime story from another world, so to speak. I'm seeing the comments. Now, without further ado, let us start a book called On the Origin of Species, as written by my boy Chuck Darwin. Introduction. When on board HMS Beagle as naturalist, I was much struck with certain facts in the distribution of the inhabitants of South America, and in the geological relations of the present to the past inhabitants of that continent. These facts seem to me to throw some light on the origin of species, that mystery of mysteries, as it has been called by one of our greatest philosophers. On my return home, it occurred to me in 1837 that something might perhaps be made out on this question by patiently accumulating and reflecting on all sorts of facts which could possibly have any bearing on it. After 5 years' work, I allowed myself to speculate on the subject and drew up some short notes. These I enlarged in 1844 into a sketch of the conclusions, which then seemed to me probable. From that period to the present day, I have steadily pursued the same object. I hope that I may be excused for entering on these personal details, as I give them to show that I have not been hasty in coming to a decision. My work is now nearly finished, but as it will take me 2 or 3 more years to complete it, and as my health is far from strong, I have been urged to publish this abstract. I have more especially been induced to do this by, as Mr. Wallace, who is now studying the natural history of the Malay archipelago, has arrived at almost exactly the same general conclusions that I have on the origin of species. Last year, he sent to me a memoir on this subject, with a request that I would forward it to Sir Charles Lyell, who sent it to the Linnean Society, and it is published in the 3rd volume of the Journal of that Society. Sir C. Lyell and Dr. Hooker, who both knew of my work, the latter having read my sketch of 1844, honored me by thinking it advisable to publish, with Mr. Wallace's excellent memoir, some brief extracts from my manuscripts. This abstract, which I now publish, must necessarily be imperfect. I cannot here give references and authorities for my several statements, and I must trust to the reader, reposing some confidence in my accuracy. No doubt errors will have crept in, though I hope I have always been cautious in trusting to good authorities alone. I can here give only the general conclusions at which I have arrived, with a few facts in illustration, but which, I hope, in most cases will suffice. No one can feel more sensible than I do of the necessity of hereafter publishing in detail all the facts, with references, on which my conclusions have been grounded, and I hope in a future work to do this, for I am well aware that scarcely a single point is discussed in this volume on which facts cannot be adduced, often apparently leading to conclusions directly opposite to those at which I have arrived. A fair result can be obtained only by fully stating and balancing the facts and arguments on both sides of each question, and this cannot possibly be here done. I much regret that want of space prevents my having the satisfaction of acknowledging the generous assistance which I have received from many naturalists, some of them personally unknown to me. I cannot, however, let this opportunity pass without expressing my deep obligation to Dr. Hooker. Just redoing my face, 1 second. Who for the last 15 years has aided me in every possible way by his large stores of knowledge and his excellent judgment. In considering the origin of species, it is quite conceivable that a naturalist, reflecting on the mutual affinities of organic beings, on their embryological relations, their geographical distribution, geological succession, and other such facts, might come to the conclusion that each species had not been independently created, but had descended like varieties from other species. Nevertheless, such a conclusion, even if well-founded, would be unsatisfactory until it could be shown how the innumerable species inhabiting this world have been modified so as to acquire that perfection of structure and co-adaptation which most justly excites our admiration. Naturalists continue to refer to external conditions, such as climate, food, etc., as the only possible cause of variation. In one very limited sense, as we shall hereafter see, this may be true. But it is preposterous to attribute to mere external conditions structure, for instance, of the woodpecker, with its feet, tail, beak, and tongue, so admirably adapted to catch insects under the bark of trees. In the case of the mistletoe, which draws its nourishment from certain trees, which has seeds that must be transported by certain birds, and which has flowers which separate sexes, absolutely requiring the agency of certain insects to bring pollen from one flower to another. It is equally preposterous to account for the structure of this parasite, with its relations to several distinct organic beings by the effect of external conditions, or of habit, or of the volition of the plant itself. The author of the Vestiges of Creation would, I presume, say that after a certain unknown number of generations, some bird had given birth to a woodpecker, and some plant to the mistletoe, and that these had been produced perfect as we now see them. But this assumption seems to me to be no explanation, for it leaves the case of the co-adaptations of organic beings to each other and to their physical conditions of life untouched and unexplained. It is therefore of the highest importance to gain a clear insight into the means of modification and co-adaptation. At the commencement of my observations, it seemed to me probable that a careful study of domesticated animals and of cultivated plants would offer the best chance of making out this obscure problem. Nor have I been disappointed. In this and in all other perplexing cases, I have invariably found that our knowledge, imperfect though it be, of variation under domestication, afforded the best and safest clue. I may venture to express my conviction of the high value of such studies, although they have been very commonly neglected by naturalists. From these considerations, I shall devote the first chapter of this abstract to variation under domestication. We shall thus see that a large amount of... again. My face died again. Give me 1 second. I will not be responding to those comments, even though I just laughed at them. Under domestication, we shall thus see that a large amount of hereditary modification is at least possible, and what is equally or more important, we shall see how great is the power of man in accumulating, by his selection, successive slight variations. I will then pass on to the variability of species in a state of nature, but I shall, unfortunately, be compelled to treat this subject far too briefly, as it can be treated properly only by giving long catalogues of facts. We shall, however, be enabled to discuss what circumstances are most favorable to variation. In the next chapter, the struggle for existence among all organic beings throughout the world, which inevitably follows from their high geometrical powers of increase, will be treated of. This is the doctrine of Malthus, applied to the whole animal and vegetable kingdom. As many more individuals of each species are born than can possibly survive, and as, consequently, there is a frequent, recurring struggle for existence, it follows that any being, if it vary however slightly in any manner profitable to itself under the complex and sometimes varying conditions of life will have a better chance of surviving and thus be naturally selected. From the strong principle of inheritance, any selected variety will tend to propagate its new and modified form. This fundamental subject of natural selection will be treated at some length in the fourth chapter, and we shall then see how natural selection almost inevitably causes much extinction of the less improved forms of life and induces what I have called divergence of character. In the next chapter, I shall discuss the complex and little known laws of variation and of correlation of growth. In the 4 succeeding chapters, the most apparent and gravest difficulties on a theory will be given, namely, first, the difficulties of transitions, or in understanding how a simple being or a simple organ can be changed and perfected into a highly developed being or elaborately constructed organ. Secondly, the subject of instinct, or the mental powers of animals. Thirdly, hybridism, or the infertility of species and the fertility of varieties when intercrossed. And fourthly, the imperfections of the geological record. In the next chapter, I shall consider the geological succession of organic beings throughout time. In the 11th and 12th, their geographical distribution throughout space. In the 13th, their classification or mutual affinities, both when mature and in embryonic condition. And in the last chapter, I shall give a brief recapitulation of the whole work and a few concluding remarks. No one ought to feel surprised at much remaining as yet unexplained in regard to the origin of species and varieties, if he makes due allowance for our profound ignorance in regard to the mutual relations of all the beings which live among us. Who can explain why one species ranges widely and is numerous, and why another allied species has a narrow range and is rare? Yet these relations are of the highest importance, for they determine the present welfare and, as I believe, the future success and modification of every inhabitant in this world. Still less do we know of the mutual relations of the innumerable inhabitants of the world during many past geological epochs in its history. Although much remains obscure and will long remain obscure, I can entertain no doubt, after the most deliberate study and dispassionate judgment of which I am capable, that the view which most naturalists entertain, and which I formerly entertained, namely that each species has been independently created, is erroneous. I am fully convinced that species are not immutable, but that those belonging to what are called the same genera are lineal descendants of some other and generally extinct species, in the same manner as the acknowledged varieties of any one species are the descendants of that species. Furthermore, I am convinced that natural selection has been the main but not exclusive means of modification. As this is a bedtime story segment, I will not be responding to those particular comments, but I am glad that it has stimulated a certain amount of discussion and, shall we say, vigorous debate. 1. Variation under domestication. When we look to the individuals of the same variety or subvariety of our older cultivated plants and animals, one of the first points which strikes us is that they generally differ much more from each other than do the individuals of any one species or variety in a state of nature. When we reflect on the vast diversity of the plants and animals which have been cultivated and which have varied during all ages under the most different climates and treatment, I think we are driven to conclude that this greater variability is simply due to our domestic productions having been raised under conditions of life not so uniform as, and somewhat different from, those to which the parent species have been exposed under nature. There is also, I think, some probability in the view propounded by Andrew Knight, that this variability may be partly connected with excess of food. It seems pretty clear that organic beings must be exposed during several generations to the new conditions of life to cause any appreciable amount of variation, and that when organization has once begun to vary, it generally continues to vary for many generations. No case is on record of a variable being ceasing to be variable under cultivation. Our oldest cultivated plants, such as wheat, still often yield new varieties. Our oldest domesticated animals are still capable of rapid improvement or modification. I will break here for 1 minute to once again talk about the fox domestication project that has been happening for the past 20 to 30 years, where we are seeing the very effects that our boy Chuck has been talking about right here. We shall get into that in a future episode, perhaps. Now back to Chuck. It has been disputed at what period of life the causes of variability, whatever they may be, generally act, whether during the early or late period of development of the embryo or at the instant of conception. Geoffrey St. Hilaire's experiments show that unnatural treatment of the embryo causes monstrosities, and monstrosities cannot be separated by any clear line of distinction from mere variations. But I am strongly inclined to suspect that the most frequent cause of variability may be attributed to the male and female reproductive elements having been affected prior to the act of conception. This sentence, sorry, I will stop here once again. This sentence has always given me the chill whenever I read it, because this is exactly how genetic variation is really introduced. It is a mutation within the parental DNA, the parental DNA that then is combined in the child that introduces the variations within a species that introduces the distribution of this variation throughout the body of the species. Keeping in mind that Charles Darwin existed before we even knew about DNA, that this work was done before the existence, in their minds at least, of DNA. It makes this observation one of those very serendipitous but also very powerful ones that exist in the world. Anyway, back to Charles. I was going to say back to Chuck, but then I said back to Charles, and then it turned out to be back to Charles. Anyway, several reasons make me believe in this, but the chief one is the remarkable effect which confinement or cultivation has on the functions of the reproductive system. This system appearing to be far more susceptible than any other part of the organization to the action of any change in the conditions of life. Nothing is more easy than to tame an animal, and few things more difficult than to get it to breed freely under confinement, even in the many cases when the male and female unite. How many animals there are which will not breed, though living long under very close confinement in their native country? This is generally attributed to vitiated instincts, but how many cultivated plants display the utmost vigor, and yet it rarely or never seed? In some few such cases, it has been found that very trifling changes, such as a little more or less water at some particular period of growth, will determine whether or not the plant sets a seed. I cannot here enter on the copious details which I have collected on this curious subject, but to show how singular the laws are which determine the reproduction of animals under confinement, I may just mention that carnivorous animals, even from the tropics, breed in this country pretty freely under confinement, with the exception of the plantigrades or bear family, whereas carnivorous birds, with the rarest exceptions, hardly ever lay fertile eggs. Many exotic plants have pollen utterly worthless, in the same exact condition as in the most sterile hybrids. When, on the other hand, we see domesticated animals and plants, though often weak and sickly, yet breeding quite freely under confinement, and when, on the other hand, we see individuals, though taking young from a state of nature, perfectly tamed, long-lived and healthy, of which I could give numerous instances, yet having their reproductive systems so seriously affected by unperceived causes as to fail in acting, we need not be surprised at this system when it does act under confinement, acting not quite regularly and producing offspring not perfectly like their parents or variable. Sterility has been said to be the bane of horticulture, but on this view, we owe variability to the same cause which produces sterility, and variability is the source of all the choicest productions of the garden. I may add that as some organisms will breed most freely under the most unnatural conditions, for instance the rabbit and ferret kept in hutches, showing that their reproductive systems have not been thus affected, so will some animals and plants withstand domestication or cultivation and vary very slightly, perhaps hardly more than in the state of nature. A long list could easily be given of sporting plants. By this term, gardeners mean a single bud or offset which suddenly assumes a new and sometimes very different character from that of the rest of the plant. Such buds can be propagated by grafting, etc., and sometimes they seed. These sports are extremely rare under nature, but far from rare under cultivation. And in this case, we see that the treatment of the parent has affected a bud or offset, and not the ovules or pollen. But it is the opinion of most physiologists that there is no essential difference between a bud and ovule in their earliest stages of formation, so that in fact support my view that variability may be largely attributed to the ovules or pollen, or to both, having been affected by the treatment of the parent prior to the act of conception. These cases anyhow show that variation is not necessarily connected, as some authors have supposed, with the act of generation. Seedlings from the same fruit and the young of the same litter sometimes differ considerably from each other, though both the young and the parent, as Müller has remarked, have apparently been exposed to exactly the same conditions of life, and this shows how unimportant the direct effects of the conditions of life are in comparison with the laws of reproduction and of growth and of inheritance. For had the action of the conditions been direct, if any of the young had varied, all would probably have varied in the same manner. To judge how much, in the case of any variation, we should attribute to the direct action of heat, moisture, light, food, etc., is most difficult. My impression is that with animals, such agencies have produced very little direct effect, though apparently more in the case of plants. Under this point of view, Mr. Buckman's recent experiments on plants seem extremely valuable. When all or nearly all the individuals exposed to a certain conditions are affected in the same way, the changes at first appears to be directly due to such conditions. But in some cases, it can be shown that quite opposite conditions produce similar changes of structure. Nevertheless, some slight amount of change may, I think, be attributed to the direct actions of the conditions of life, as in some cases, increased size from the amount of food, color from particular kinds of food and from light, perhaps the thickness of fur from climate. We shall end here for today, but before I end, I just want to point out again this idea that even before DNA was a known thing, Chuck here is talking about the fact that there is some other force that drives variability within the offspring of a species. And we like that, because can you imagine if all of your progeny ended up exactly like you, especially our year 2 and year 3 students? The world would be a terrible place if your children acted exactly the way that you are doing. But the point remains, even without knowing the existence of genetic material, Darwin has here talked about the external forces which cause variability, which has nothing to do with the environment of the species itself, but rather within the genetic material within its parents. Now, that is it for today. Thank you very much for listening. In conclusion, please download Firefox, please don't do Chrome, and have a good night. See you soon.